we're going to cover the real number system. This is a way to classify numbers. So we're going to start off with natural numbers. And so you can think of these as counting numbers. When you were first learning about numbers, you probably learned how to count starting at 1. And then you went to 2, 3, 4, and so on. That was the beginning. And then you can move on to whole numbers, which you can think of as counting numbers plus 0. So we started with the most exclusive type of counting, which is only just 1, 2, 3, 4, 5, 6, 7, and so on. We're moving out a layer, and so now we get to whole numbers, which is 0, 1, 2, 3, 4, and so on. Moving out a further layer, we get to integers. And integers are counting numbers, their opposites, and 0, of course. We started with natural numbers, 1, 2, 3, 4, and so on. We added on whole number of 0, and now we're saying they're opposites. So this is when maybe later elementary school, you got into negative numbers. So we're going to include the opposites, -1, -2, -3, -4, and so on. Moving out another layer, we get to rational numbers. And this would be any number that can be written as a fraction. So this includes repeating decimals and decimals that terminate, also known as end. So an example of a rational number could be something like -3/1. That's including the opposites that we picked up from integers, and we're able to express it as a fraction. And now we've finally gotten out into the real number area, which includes the rational numbers and the integers and the whole numbers and the natural numbers. But actually, over on the side here, we also have a different type of number. Over here, we have irrational numbers. And so they are their own separate section, but they fall under the real number system. And so what are irrational numbers? Those would be numbers with an infinite number of decimals that never repeat. What could that be? Are there any irrational numbers that we know? Well, perhaps you've heard of pi, which we say it's approximately 3.14159, but it really keeps going on forever. Also, if you typed it into the calculator, you might discover that the square root of 2 is irrational.